In this video, let's learn some important terms related to a conic. In a coordinate plane, let's assume that this board itself is a coordinate plane. Let S be a fixed point and L be a fixed line. S is a fixed point and L is a fixed line. When I say the fixed point, you must note that the coordinates of the point S do not change with respect to time, and the line is fixed in the coordinate system. Now let me consider P, a point P which is moving. P is a moving point. For a moving point, the coordinates keep changing with respect to time. I will join SP and draw PM perpendicular to the fixed line. Now we have two distances here. One is SP and second is PM. SP is the distance between the fixed point and the moving point. PM is the perpendicular distance drawn from point P, onto the line, the fixed line. So notice these two distances, one is SP and other is PM. Now we have the ratios of these two distances. I take the ratio of SP to PM, that is length of SP divided by length of PM. SP can be 5 centimeters, PM can be 8 centimeters. In that case, supposing let's assume that SP is 8 centimeter and PM is 5 centimeter. Then what is the ratio? The ratio becomes 8 by 5. And 8 by 5 is greater than 1. If this ratio happens to be greater than 1, then the conic is called a hyperbola. Remember, for a hyperbola, the ratio of SP to PM will be always greater than 1, and the name of the conic is hyperbola. The value of the ratio, as we have in this example, 8/5, which is a constant, and this constant is known as eccentricity of the conic, denoted by E. So, for an hyperbola, E is greater than 1. Now I will consider the ratio SP to PM, which is known as eccentricity of the conic, and in this case, let us say that eccentricity value is less than 1. Like, in that case we take it as 5 by 8, for example. Then the conic is called, if E is less than 1, then the conic is called ellipse. So ellipse is a conic whose eccentricity is less than 1. Or the locus of P is such that the ratio of SP to PM is always less than 1. And that is ellipse. Supposing SP to PM, that is eccentricity. If eccentricity is equal to 1, then the locus of P is called a parabola. So how do you define a parabola? A parabola is a conic section whose eccentricity is equal to 1. Or the locus of P, or the point P moves in such a way that the length of SP will be always equal to length of PM. If this is 5 units, then PM is also 5 units. In the last case, suppose this ratio gives you 0. That is, eccentricity value is 0. Then the locus of P is called a circle. So you can also remember a circle is a conic section whose eccentricity value is 0. So remember that if E is greater than 1, then it is hyperbola. If E is less than 1, then the conic is ellipse. If E is equal to 1, then the conic is a parabola. And if E is equal to 0, then the conic is a circle. E is a constant. The value of the ratio that you get when you divide the length of SP and PM. When the length of SP divided by PM, whatever the numerical value you get is called as eccentricity. And these are the 4 eccentricities of 4 different conics. The fixed point, what we spoke about, in future it is called as focus of the conic. Focus denoted by alphabet S. And the fixed line that we have referred to is called directrix. Directrix of the conic. So we have understood 3 terms now. One is the focus of the conic, which happens to be a fixed point in the coordinate plane, and the directrix of the conic, which will be a straight line in the coordinate plane, and the point P, which is a moving point, it describes a hyperbola if the value of eccentricity is greater than 1. The locus of P will be ellipse if P moves in such a way that SP to PM ratio is less than 1, then we get ellipse. If E is equal to 1, that is if SP is equal to PM, say this is 5 again and this is 5 again. Now let us say this point, SP is 5 and 5. Let P go over here. Now SP is 5 and again PM is 5. Now when you join all these points, then the curve what you are getting is the locus of P. In that case, it's a parabola. If E is equal to 0, then remember the conic is an ellipse.